How can we find the angle between two intersecting planes? Well, take a look at my diagram here. We have a purple plane and a green plane, and you can see that they intersect one another. Now, if we're interested in finding the angle between them, let's say this angle here, then really all we have to do is figure out the angle between the plane's normal vectors. What I mean by that is if you have a normal vector to the green plane here and a normal vector to the purple plane here, and you move this normal vector down here so that it intersects the other normal vector, then the angle between these two vectors will be exactly the same as the angle between these two planes. So all we have to do is figure out what the normal vectors are, right? And to do that, all you need are the equations of the planes. So for this example, the first plane we have, the green plane, has the equation 0x plus 0y plus 1z plus 0 equals 0. Now you might say, why don't I just write this as z is equal to 0? Why am I adding all these extra terms? I'm just doing that to keep our general form, our ax plus by plus cz plus d equals 0. Normally you wouldn't have to do this. You could just write z equals 0. It means the same thing, but I want to keep that form. Our other equation for the purple plane is 0x plus 1y plus 1z plus 2 is equal to 0. And again, you don't have to write this first term 0x. I'm just writing it to keep the form. Now, if these are the two equations of the planes, then the normal vectors are as follows. Normal vector 1, so the normal vector for the first equation will be 0, 0, 1. You just get those values from the coefficients on x, y, and z. And the normal vector for the second plane will be 0, 1, 1. Okay, perfect. Now, how do I find the angle between these two vectors? Well, if you ever need to find an angle between two vectors, you can simply use the dot product. Remember, the dot product says that two vectors dotted together will equal their magnitudes multiplied together multiplied by cosine of the angle theta, where the angle theta is the angle between the vectors. So this is fantastic. I can isolate for angle theta, and if you do that, you'll get theta is equal to cosine inverse of the dot product between normal vector 1 and normal vector 2 divided by the magnitude of normal vector 1 and normal vector 2, like that. So I will use these two vectors. I will plug in the information into this equation, and by doing so, I will determine the angle theta, the angle between the vectors, which is the same as this angle between the planes. So let's clean this up a little bit. Okay, I've got my two vectors, I've got my equation, let's plug everything in. Theta is equal to cosine inverse. Now the dot product between these two vectors will be 0 times 0 plus 0 times 1 plus 1 times 1, okay? The magnitudes of the vectors will be the square root of 0 squared plus 0 squared plus 1 squared multiplied by the square root of 0 squared plus 1 squared plus 1 squared. If you do all of this, you'll get theta is equal to cosine inverse of, well, on the top you're just going to have 1, and in the denominator you'll have this first root turns into just 1, right? Square root of 1 squared, it's just 1. And then over here you have 1 plus 1, which is equal to 2 square root 2. So 1 over root 2. If you take the cos inverse of 1 over root 2, you get 45 degrees. So the angle theta, the angle here and here, must be 45 degrees. So that's the angle between our planes. And that looks to be about correct. Now, this was a very simple example, right, where my planes were very basic. One plane is just horizontal, the other plane is just elevated slightly, right? It's a very, very nice example with very simple equations and simple normal vectors. We can also do an example where the planes look a little bit more complex. So let's say these are your planes here. You can see it's a little more complicated. They're both kind of diagonal with each other, and you have to kind of turn this around to see those angles at which they intersect. Now I have the equations for these planes as well. The red plane has the equation x plus 2y plus 3z plus 4 is equal to 0, and the equation for the blue plane is negative x plus 5y minus 2z plus 7 is equal to 0. So I do the exact same process here to find the angle between them. I use the normal vectors. The normal vector for the first plane will be 1, 2, 3. Just getting those from the coefficients on x, y, z. And the normal vector for the second equation will be negative 1, 5, negative 2. Again, from here, negative 1, 5, negative 2. I can then plug my information into my equation. Remember, the equation is theta equals cosine inverse. You have a bracket here. On the top of the fraction, you have the dot product between these two. I think we can just do the dot product directly. 1 times negative 1 plus 2 times 5 plus 3 times negative 2. Fit it in there like that. And on the bottom, we have the magnitudes. So the magnitude of the first vector, 1 squared plus 2 squared plus 3 squared, multiplied by the magnitude of the other vector, 1 squared plus 5 squared plus 2 squared. You could plug in negative 1 squared and negative 2 squared instead, but you're going to get the same thing when you square them, so I don't really bother doing that. And if you calculate this, what you should get is cosine inverse of 3 over, so the top becomes 3. This root here becomes root 14, and this root here becomes root 30. If you calculate this, you should get about 81.58 degrees. That is the angle between the normal vectors, which means it's the angle between the planes. If you're interested in finding the equation of the line where these planes intersect, make sure you watch the next video.